that's one thing in the last class, I forgot a lot of this stuff. And on the laser class, laser orientation stuff, and the laser engraving, I took video, so I was able to go back and watch it. And good resource.
So it's right at 8 millimeters. So that is our bearing diameters and measurements, so we know what we need there.
Okay.
Make sure this took because I didn't actually bother it. Yeah, okay, cool. So we're going to sketch a circle, center diameter circle. We're going to start at the origin point because that's what we do. And we are going to make this the bearing diameter. So that is going to be the inside point that we slip this bearing into. So now we need an exterior on the same center. So again, circle, we'll go to the same center. And we can do bearing diameter plus 10 millimeter. And that'll give us that outside. So what we have right now, if we extruded from here, you would see you can do the real simple mechanism. We pull up just a little bit. You'd be able to slip our 608 bearing into the inside of that particular piece that we have now.
Okay.
We're not going to actually extrude right now, but we're going to do something again. What we can do here is we can actually copy these. If the mouse would function. If we do copy, which actually should be M for move. If you'll notice it is move copy. We're going to do a freeform move, which is this first little signal here. You can also do point-to-point moves. We're not going to do point-to-point. I'm not sure why I said 4, but we are going to create a copy.
Okay.
So we're going to move this somewhere over here. It doesn't really matter.
Now, is this going to be kind of one of those spinners that has the 3 exterior, or?
So I'm going to show you how to either do 3 or 4 or 8 or 12 or however many you want, and also you'll be able to adjust the distances between them.
Okay.
Yep. So we're going to do OK because it's going to create that copy, and now we're going to do D for dimension, and we are going to dimension this movement from one. Did not take D. Should be that one. Should be that one. Hello. Okay, maybe it didn't. So that one. Some days. That one. Yeah, there it goes.
Cool.
Oh. So we'll pull them up here. And we'll say whatever that is. What we can do is we can set that to whatever we want to do. Let's say 30 millimeters. Oh, I didn't catch both. Oops. Okay. So if we do D for dimension, and then we're going to hit shift. No, it's still on. Dang it. Alright. Alright, I'm not going to worry about it right now. Well, actually, we kind of have to. Alright. So how did I do this last time? maybe I grouped them. That's probably what I did. Hold on. Alright, so. Maybe I did it after the revolution. We'll see. Alright. So now we need to combine these two, and you can do this in any number of fashions. We can do a straight line. And you can just select anywhere on that circle. And then anywhere over here on this circle. And what we can do is you can select this one. And then come down here to tangent and select the circle, and it'll automatically make a tangent. We do the same thing here. We select this and say tangent to this circle. Fusion is really trying me today. All right. So, tangent here. And then let's do this tangent. Oh, it still did it the wrong way.
You know this better than I do, but if you selected the end point instead of the line, would it have potentially helped?
To be honest, I don't know at this point because I thought it automatically did the coincidence, but maybe. Oh, I know what it is. I know what it is. It's because I don't have this defined. Okay. There he goes. All right. So what happened there
Yeah.
was that I did not have this other circle defined as fixed. So if you right click, you'll see fix unfixed. If you fix it, that means it will not be able to move it. And so then it knows I need to move the line rather than the circle.
And why wouldn't it have just shortened the line and tangent?
Sometimes it will. It depends on how long it is. We can also double check that here in just a second.
So I don't remember us setting a specific distance from one center point to the other.
So if I do a line here, to here,
Uh-huh.
which is obviously way too long. Let's do this, and then tangent to this, and then this, tangent to this. So it didn't automatically trim it, it just made it tangent. But we can just trim it with a simple T command.
So you just click on it and then hit T?
Mm-hmm.
Okay.
Actually, if you just hit T, it'll bring up trim.
Oh, okay.
And from there, you can just trim objects out.
Okay.
Like technically, if you wanted to right here, you could actually trim out this little half circle. I don't suggest doing that necessarily in this because we're going to actually do something that'll actually involve this.
Okay.
But you can do it that way.
Okay.
So now that that is all set, what we are going to do is we're going to go ahead and extrude this as an object, and what we're going to do is we're going to select the two circles and the body in between. If you'll see up here in the profile, it says 3 selected. The distance we're going to give is going to be the bearing height. Bearing thickness is what I named it, I'm sorry. I'm going to say okay. And there we go. So that would be pretty acceptable little 2 single spin fidget. So what we're going to do though is we are going to do, let's see if it'll let me do this. If I can select the whole body. So we're going to select that body, and then we're going to go to sketch. Oh, I'm sorry. Create pattern, circular pattern. So pattern type bodies. The object is the one body that we have, and now we need to select our axis. We're going to select this axis, which is basically the z-axis, and then you'll see right now we have 3 selected. If we do 8,
Well,
it'll do 8. If we do 9, do 9. Obviously, there comes a point at which the bearings are going to start to intercede with each other and such.
mm-hmm.
But you can just say okay. Now, the one thing with this is, if you'll see, all of these are individual separate bodies. So I'm actually going to roll this back one because I actually don't want 12 of these. I'm going to do the standard 3. And again, we'll go to create pattern, circular pattern. We're going to choose, see it says faces. We don't want to do faces, we want to do bodies. This body, this axis. You'll see there's also a full, an angle, and a symmetric. We want full. I don't remember what suppress actually does, but we're going to say okay here. So now you have all 3 of these bodies. If we select all of them, over here in the tree, we can go to modify, and then combine. So we want to join, and we're going to keep whatever term. We're going to say okay. Which actually still didn't do all of them. Oh, I know what happened. All right, so we're going to modify. Actually, let's do this. Let's roll it back one to make sure. Once again, the great thing about parametric, you have a timeline. So we're going to delete that. And then we're going to not keep the tool bodies. Modify, combine, turn off keep the tools. And that should combine all of them. Yeah, so now we just have the one body in total. This would be a perfectly acceptable little fidget spinner, especially for people that have decent sized hands. My tiny little hand will not do that, however. But what you can also do from now is you can chamfer. So, oh, that's not actually the right one. If we do S, it actually brings up a model shortcuts. I also refer to S for search because it kind of gives you just this little search bar where you can actually search for what you're looking for. As it turns out, what we want actually right here is this fillet. And then we are going to select all the edges that we want to fillet.
Holding control.
Yep, shift.
Shift.
So we're going to select those 3. It's giving me 9 edges because it's counting each one of these as a separate edge,
Okay.
even though it's one body. And then we are going to tell it how much we want to. We're actually going to do this at, I know we can do bearing height, bearing thickness, divide by 2.
Huh.
And there it goes. Now if we rotate it over so we can see it. Now the thing to keep in mind is we are 3D printing, so one of these surfaces is going to be flat on the glass. You could leave it here, and of course most people would not notice that there was a fillet there at all. They wouldn't notice that there was a lack of a fillet on this side. But since we're modeling and we're trying to have kind of decent memories of this, or decent practices, we're going to go ahead and fill it. We're going to select these 3. And then we're going to do bearing height. There thickness, if I can ever remember what it's actually called. Divide by 2. We say OK. And you can see now it's a nice smooth edge all the way around. I also very much suggest either chamfering or giving yourself a nice little fillet right here.
Yep.
So the S, fillet. Actually, I'm gonna do a chamfer here. Let's do S, chamfer. Anywhere that we're gonna put a bearing, at least on one side. And it doesn't have to be much. We'll call this one 2 millimeters. And that still looks actually kind of like a lot, but okay, let's actually roll that back around. So, S for search, chamfer. Let's just do like a 0.5 millimeter chamfer. See what that looks like. Let's do 1 millimeter. Looks a little bit better. And of course, the chamfer is going to help you actually seat that bearing in there a little bit easier.
Oh yeah.
In general, I know we don't do a lot of machining, especially in a lot of thought on the manufacturing process when we're doing design. I like to kind of keep it in mind because a lot of times I'm going to be the one that's actually designing and then engineering it as well. So it kind of helps. And I think it helps in the design process too if you remember how you're going to manufacture something. So anytime that I am designing for anything that's going to be machined, I try to break the edges with at least a little bit of chamfer, just because, especially if I know parts are going to go together, because in general, machinists don't leave sharp edges. They just don't. It's a bad idea.
Yeah. I got an associate degree as a machinist.
Yeah, it encourages burrs and scraping and all sorts of other stuff. So generally, you're going to chamfer it over, at least with a file, real quick anyway. So nobody likes sharp edges, unless that's really what you're looking for. I'm also going to give a little bit of fillet on these insides. So we're going to select this one, and this one. And let's see if what the 3.0 looks like. Doesn't look like much. Unless 6 millimeters. A little bit more. How about 20 millimeters? Interesting. 10 millimeters, sure. We'll leave it there. So yeah, nice and smooth. Pretty easy to see. Alright, so this may be great for most people to be able to use, but like I said, my tiny little hand is probably not going to deal with that very well. I do not play piano. So we're going to turn on the sketch, we're going to turn off the body, and if you'll see, the only thing that's actually sketched is still this part.
Yeah, that's cool.
So if we go for M for move, we're going to choose sketch objects, and then we're going to select, oh wait, it may not, let's edit sketch. So that's why I wasn't highlighting anything, that's because it wasn't on sketch edit. Alright, so we're going to do M for move, we're going to select select these two. Let's do point to position. Start at the center point here. We'll start there. Oh, no. It's not going to let me do that. Okay, we'll just freeform it then. either because it's grounded. Fix, unfix. Now let's move. Oh, I fixed these apparently. Golly. What's going on today? Okay. Fix, unfix. Freeform, we have two objects selected. Let's just move it back to about there. Say OK. Stop sketch. And we turn the body back on. Nice and short for my fat little fingers. And so there we are. And that's pretty much it. You can also design some of the caps that go into them and all that kind of good stuff. And we sometimes do that. I mean, depending on if you want to mess with it, we can. It's not that hard. It's basically just 3 stacks of circles.
What do you mean by caps that go in 3 stacks of circles?
So you snap this bearing into each of those holes, and then you're supposed to hold it and spin it. If you put caps on the ends, you get a little bit better because your fingers aren't getting in the way of everything.
Okay.
Those are not terribly hard. I'm gonna do one of those real quick. All right, so we want to do a new component here. We're gonna rename it. Maybe. Alright, so we want to go to sketch, create sketch. We're going to sketch along this plane, but we're not going to sketch anywhere near this particular model. So we're going to go C for circle. Don't really have to be on that line anyway because we're not referencing it for anything. We're going to select here, and this will be the inside, so this needs to be D for diameter or dimension, whichever you want it to. Technically it's dimension. Why is it? Man, it's really not keeping up today. There it is. Good grief. We're going to do bearing, inner diameter, and then we will minus 0.1 millimeters just to make sure it slips in. Actually, we won't. Let's not, because these aren't hard. We're going to be using plastic. It's fine. We can always carve a little out manually if we have to. And then we need to extrude this because it's just a real simple circle. So we're going to extrude this, and this is going to be bearing thickness divided by 2 because we're going to do 1 on each side, so we only want them to go halfway in. So we're going to say half. So there we have our little bearing or beginning. The next thing we're going to do is do another sketch.
Now, would you potentially want that to stick up a little bit to have, if you're spinning it, maybe?
Yeah.
Don't care. I mean,
yeah, you might go over a little bit. I tend to not, just because I'm going to do a shoulder that's actually going to sit right here on top of the bearing.
Oh, okay.
And that's what we're going to do right now. So we'll do create a sketch, and we're gonna sketch right on top of this little piece that we just made.
Now
We're
I
gonna do
got
C
you.
for circle. It snaps to the center. So now, if you do a real quick measurement on that bearing, that inside race is about 11 millimeters wide, or 11 millimeters diameter. Okay, so it already did this circle. Man, this thing's really being buggy today. I don't know what's going on. 'Cause I'm not sure that actually hit the center. So we're going to say 11 millimeters for the shoulder here.
Yeah.
So when the computer ever catches up.
Is it waiting on? I was gonna say. No,
Well, usually it just assumes.
I would think so too. Oh, you got 2 decimals.
Oh, do I? Okay. Well, that makes sense then. Hey, cool. When the monkey using the computer actually does things right, it works well. Okay, cool. So again, E for extrude. However, what's funny about this is because we started again, we've seen this before in other sketches. If you start sketching on top of a body you already have, for some reason it will actually exclude that body from the extrusion, even though you want to include it. So we're going to include it, and we're going to go up 2 millimeters. I mean, it really doesn't have to be a lot because it's just got to hold that shoulder. And then we're going to do yet another sketch on top of this body because we want another circle. We're going to put it in, hopefully the center. There it goes. And this time we want it to be very much wider than our actual bearing. So we know our bearing's 22 millimeters. We already have that measurement in our parameterization. So let's call it bearing diameter. And then we're going to do like plus 3 millimeters. And then again, we're going to extrude. We'll include both. And we'll do 5 millimeters. And there you can see a nice little cap. Actually, I'm going to go back and redo that extrusion. I'm not going to go quite as high as that. Let's do like 3 millimeters. Delete that part. Okay, yeah. So just don't like how thick that was. But yeah. So there is the other part. So now that we're done with all of that, we can go back to our root directory. Let's clap some stuff down so it looks a little bit easier. Hello? Alright, cool. And there's our 2 parts. Now, to export these into some sort of file format that the slicing software that any 3D print program uses anywhere, these need to be STL files. So what we're going to do is we're going to go up here to make 3D print. And now it's going to ask you for a selection. So we're going to select this body. And if you'll see it says preview mesh, that's fine. You can preview the mesh if you want. The refinement you can use on pretty much any for this, it's fine. The output, however, you do not want to do a 3D print utility. Now, obviously you can, and if you wanted to send this out to one of these other programs that you could actually ship it to, you could do that. Obviously, Autodesk wants you to use Mesh Mixer because, hey, they own that, so why not? So we're just going to say no, and we're going to say okay, and at that point it's going to ask us to actually save this as an STL file. I'm usually going to use a flash drive because we can't save to the PC.
You got one if you don't.
Hey, maybe got it in right. Yeah, there. Must be lit back. So we're just gonna save it here on the directory. Alright, so that's done. And now we need to do the other. Again, 3D print, it asks you for selection. We're gonna select this one. Let's not preview the mesh. And then we're gonna say okay. STLs, okay, I don't know why it does body one for that. Oh. Make sure it's getting everything there. Make 3D print. Okay, so it is getting the whole body. Alright, cool. And it did fidget cap this time. Okay. I must have just selected that top body the first time, and that's why I didn't like it. So, okay, cool. Fair enough. Selecting the entire thing won't make a difference. And that is something else we can do. We can go in to the fidget cap. If you want to clean this up and make this a little bit easier, you could actually go to combine again. Select that body. Oh, actually it didn't. Okay, cool. Alright, so I did save it as a whole body. Alright. Yeah, okay, cool. So even though you had multiple sketches, it still saved it as one body. Alright, fair enough, good. Alright, cool, fantastic. Alright, so now that we have that done, I did not actually want to start that. I want to continue without scanning. I don't want to look at this. Please stop. We're going to eject our disk and go over to the printer.